For each of the following relations, determine their inverse. Okay, let's begin with the first relation. So here we have a relation R, which consists of 5 ordered pairs. So here 1, 2, 1, 3, 2, 3, 3, 2, and 5, 6. Okay. Now, using this relation, let's try to find out the inverse. Now, how do we define the inverse of any given relation? The inverse of any given relation R is defined as the set of ordered pairs B, A such that we have the ordered pair A, B belonging to the relation R. So, if we have A, B as the ordered pair belonging to R, all we have to do is interchange the position of the elements in the ordered pair. That means the first element, which is A, goes to the second position, and then B, which is the second element in the ordered pair of the relation R, comes to the first position, and that's going to give us the inverse of the relation. So in other words, all we have to do is consider the first ordered pair, which is 1, 2. So we will interchange the position of the elements to get 2, 1. The next element is going to be 3, 1. Next will become 3, 2. Then we have 3, 2, so that becomes 2, 3. And then we have 5, 6, which is going to become 6, 5. This is as simple as that. So we have obtained the inverse of the relation for 1. Okay, let's come to the second one. So here we have the relation R, which is the set of the ordered pairs x, y such that x and y are natural numbers, and it fulfills the condition that x plus 2y equals to 8. Okay, so first what we'll do, we'll try to convert the relation R into the set of ordered pair. So for this we will consider the equation x plus 2y equals to 8. Okay, so let's isolate y from here. So y is going to be equals to 8 minus x whole divided by 2. So we're going to consider some values of x. So if we consider x to be equals to 1, then y is going to be equals to, so 8 minus 1, that's 7 over 2, but 7 over 2 is not equals, does not belong to the set of natural number, because it's clearly mentioned that y must be a natural number. So we have to choose very specific values of x. So if we choose x to be equals to 2, then in that case y is going to become equals to 3. 3 is a natural number. If we choose x to be equals to, we cannot choose 3 being an odd number, so we go to the next number, which is an even number, 4. So when we choose x to be equals to 4, y will become equals to 2. If we choose x to be equals to, let's say 6, then in that case we have y equals to 1. However, if we choose x to be equals to 8, then our y value goes to 0, and this is again not a natural number. So that means this does not belong to the set of natural number, and any values greater than 8 that we consider, we will get negative number. So we are going to reject all this number. So x can take only these values, 2, 4, and 6, and the corresponding y values are going to be 3, 2, and 1. In other words, we have a relation. So here if we choose x to be equals to 2, then 2 is going to be related to 3. Then we have 4r2, and then we have 6r1. So these are the 3 possibilities. So that means our relation R is going to consist of 3 ordered pairs. So 2r3 will be denoted by 2, 3. This is the ordered pair. Next we have 4, 2. And then we have 6, 1. So these are the ordered pairs for the relation R. Now that we have R, we can find out its inverse. So what will be the inverse of the relation? So that's simply going to be, so 2, 3 becomes 3, 2. Then we have 4, 2, that becomes 2, 4. And then we have 6, 1, so that becomes 1, 6. So this is going to be the inverse relation of the relation R. Okay, fine. Let's go to the third problem. Now in the third problem, we have R, a relation from this set to this set, which is defined by y equals to x minus 3. So let us suppose by considering A to be the set which is given by the set containing the elements 11, 12, and 13. Right. And then we have the set B. So set B contains the elements 8, 10, and 12. Okay. Now using these two sets, we're going to define a relation R such that we have y equals to x minus 3. So let us consider x to be equals to, So here we are supposing x belonging to the set A and y belonging to the set B. Fine. So we have x equals 11, which implies that y must be equals to, we have 11 minus 3. What's 11 minus 3? So that's 8. So we have a relation 11R3. So when we choose x to be equals to 11, then y is going to become equals to 8. So that's 11R8. So this is a relation. Next, we will choose x to be equals to 12. So when we choose x to be equals to 12, then the corresponding y value, that's going to be 12 minus 3. So that's 9. Is 9 an element of the set B? No, 9 does not belong to the set B. So we're not going to consider x to be equals to 12. Let's now choose x to be equals to 13. So when we choose x to be equals to 13, then in that case y comes out to be equals to 10. And since 10 is an element of the set B, this simply implies that we now have a relation 13R10. Okay, so now we are ready to define the set. That means the relation R. So R is going to be the set containing the ordered pair. So 11R8 is going to become 11, 8, and 13R10, that's going to become 13, 10. This is our relation. And now that we have the relation, it's easy to define its inverse. So that will be 8, 11. That's one ordered pair. The other ordered pair is going to be 10, 13. Fine. So this is the end of the problem.